All right, here we go. Unit 7, Lesson 5. I'm going to call this lesson U substitution. U substitution is an advanced integration technique. We're going to start off with a refresher of reminding ourselves of cases where we don't need U substitution. And then we're going to look at cases where they do become necessary. So, my way of teaching indefinite integrals, I know it can be kind of annoying, but I think it's just the way that ends up working best in the end. And that's kind of, I don't know, try something, see if it works, and fix it. All right, so if we have this antiderivative of 3 times the cosine of 3x, I'm going to walk you through like what I see when I see this. I see this part right here, this cosine of 3x. And what I see is there is only one thing in the entire world that I can take the derivative of it and get the cosine of 3x, and that's going to be the sine of 3x. And so this is my first guess, right? I guess that that's the answer, and I check by taking the derivative. I check by taking the derivative of the sine of 3x. The derivative of the sine of 3x is the cosine of 3x, chain rule, times 3. So I don't have to fix anything. This one actually worked out correctly. This one does work, right? Because this here, right, what's happening here is I'm taking the derivative with respect to x, and it works. So my answer right here, my answer is the sine of 3x plus c. That's going to be my final answer there, right? But it's not always going to work out that cleanly. So let's try this one here. Again, you always got to guess and check. The sine of 2x plus 3. 2 times the sine of 2x plus 3. So I start with my first guess. I think, okay, is it just the cosine of 2x plus 3? And I say, okay, let me make sure, let me check, let me take the derivative, and this would be, this is my check. Again, this is not my final answer. I haven't balked it. This would be negative the sine of 2x plus 3 times 2. Okay, so I'm missing this negative sign here. So what I need to do for my final answer, it's not this, it's going to be the cosine, negative the cosine of 2x plus 3 plus c. Now, what I am looking for when I see these problems, so here I want to give you another way to think about these. Let's say, and I think this is a good one here. Let's go to this one here. So first things first, let me just clean this up. I'd rather think of this as the antiderivative of 2x times x squared plus 5 to the 1/3, right? It's a cube root. So two ways to think about this. The way I've been saying it is look at the hardest part to make. This is the hardest thing to make. The hardest thing to make is this x squared plus 5 to the 1/3. So I would start off, my first guess would be x squared plus 5 to the 4/3. And then I would just like try it, make sure the chain rule happens, and see what I need to fix. What I want you to key in on today, though, right, is what we're going to call on the next step, license to integrate. And what do I mean by license to integrate? All I mean by that is you can kind of see the chain rule happening. See this right here? If you can identify, oh, that looks like G, and you can identify what looks like G prime, or G prime times some number K, right? So just like up or down by some number, that means you don't need the technique we're going to learn today called U substitution. And so just to finish this one off here, let's go ahead and check it. If I took this derivative, I would have 4/3 times x squared plus 5 to the 1/3. So I nailed that part. I got that part. Chain rule times 2x. Okay, so what I'm going to have out front here is 8/2, right? I'm going to have 8/2 times x squared plus 5 to the 1/3. Okay, well, I don't want 8/2. I don't want, right, that's going to be 8/2 to 2x times, we're going to have here 4/3. Did I do that right? That's going to be 8/3. I was like, something's gone off there. So this is going to be 8/3. Well, I don't want 8/3. I want 2. So I want actually here, I want to take 8/3 and I want to turn it into 2. So what I need here is 8/3 times something is equal to 2. Okay, I'm going to go ahead and multiply both sides. Yeah, this is a trickier one. This is one that it's not immediately apparent what you do in your head. So I'd think about it that way. 8/3 times what would be 2? And the answer here would be 6/8, which is 3/4. So I'm going to update this. My final answer, 3/4 times x squared plus 5 to the 4/3 plus c. This is going to be my final answer here. And if you wanted to, you could check that and you could see that it comes out to be the right answer there. You can actually kind of see why, because 4/3 times 3/4 is 1, and then the 2x is going to spit out from the chain rule. Let's do one more, because those other two are kind of similar. Let's just do one more this is a super tricky one here. So we've got a fraction here, and I'll give you a hint. You're never going to have to do the quotient rule backwards. So when you see a problem like this, you want to be on the lookout. This is a tricky one to see. And this one actually works best if you can try and identify, can I find my g? Can I find my g prime? And in this case, it sure looks like this is g and this is g prime. And so what kind of derivative ends up giving me g on the bottom? Well, it's actually going to be the natural log of x squared plus 2x. So that's a really tricky one to see. But if you were to check this, right, the derivative of the natural log of x squared plus 2x, we know it's 1 over x. So 1 over x squared plus 2x, chain rule times 2x plus 2. So this is correct. The correct answer here is the natural log of x squared plus 2x plus c. All right. Now that's a good amount, right? That's all just sort of like review of integration concepts so far. But I had to get there because it's been a while. Now we're ready for what's called U substitution. So let's take a look. We're not going to do these last ones. I'll put them in the notes so you can look at them if you want. In all of the examples above, like I said, we had license to integrate because we were able to identify, right? We were able to identify g and g prime. We were able to see what got spat out of the chain rule. But let's look at this other problem here. What does it look like the inner function is on this? It looks like it's 2x minus 1. But the derivative, the g prime, if g is 2x plus 1, is 2, right? So if you try and do like the guess and check method, if you say, okay, let me see what happens when I take the derivative of 2x minus 1 to the 4th, right, going up by 1, we'd have 4 times 2x minus 1 to the 3rd. Well, how the heck am I going to get this x, right? There's nothing I can just throw in here. I certainly can't just throw in an x, right? That's definitely probably one of the most common mistakes. You can't just throw in that x there because then you get the product rule going on. It's way harder than that. So that's actually not what's going to work. And so here is the technique known as U substitution. So no and no, we cannot just get that by multiplying by a constant. All right, here we go. Tricky. Step 1, identify the inner function. Okay, so U, the inner function here, is equal to 2x minus 1. The inner function here is equal to 2x minus 1. And this is all going to be like, why are we doing all this? And it's all going to click together in the end. Step 2, find du and solve the equation for dx. So what I'm going to do here is I'm going to take the derivative with respect to x of both sides of this equation. So I'm going to take the derivative with respect to x of both sides of the equation. That gives me du, the derivative of u with respect to x is equal to, well, the derivative of 2x with respect to x is 2, and the derivative of negative 1 is 0. So du over dx equals 2, and it says here solve for dx. Okay, well, this means, right, this implies, going to do a little trick here, this implies dx over du is equal to 1/2. So dx is equal to 1/2 du. A little A little bit of fancy footwork there. You could have also multiplied both sides by dx and then divided both sides by 2. But flipping both sides by making this 2 over 1 was a little trick there. All right, so we have dx. Here's another step. Find an expression for x in terms of u. Find an expression for x in terms of u. Okay, well, that just means take this and solve for x. So we'd have u plus 1 is equal to 2x. X is equal to u plus 1 over 2. And I know this seems like a lot, but just try to remember, let u equal the inner function, find du, and find x. And so here's why this is going to be helpful. Let's check this out here. Let's see what happens here. If we take the original integrand, x times 2x minus 1 to the third, right? Crazy integral that we're not going to be able to do otherwise. And what I'm going to do is I'm just going to one by one show you this substitution. X, we showed, was the same thing as u plus 1 over 2. We're trying to basically make it so that we can figure this out using the chain rule. 2x minus 1, well, that's u. We define that to be u to the third power. And here is why this is going to be super helpful. If we go ahead and we replace, dx with 1/2 du, we replace it with 1/2 du, now we have this integral expression that only has u and du. The reason this is super helpful is that because it's just u cubed, I can just multiply all this stuff out. So we have this 1/2 and this divided by 2. I'm going to make our life easy. I'm going to bring this out as 1/4. So we have 1/4 times the integral of u plus 1 times u cubed times du. So what does that mean we have? Well, it means we have 1/4 times the antiderivative of u to the 4th plus u to the 3rd du. And this is 100% something we can do. All this is 1/4 times 1/5 u to the 5th plus 1/4 u to the 4th plus c. That's all. And you could multiply this all out. You could get 1/20 times u to the 5th plus 1/16 u to the 4th plus c. Now here's the crazy part. Now we can go back to x. And so check out this insane derivative that we were able to find. We were able to find that 1/20 times u is 2x minus 1. U is 2x minus 1 to the 5th. I'm going to erase this arrow. Plus 1/16 u to the 4th plus c. There is absolutely no way that we would come up with that definite integral on our own. And it's one of those things where I'm like, okay, if you want to take a whole piece of paper proving it, you can. Trust me, it would work out. That is the actual antiderivative of x times 2x minus 1 to the 3rd. Now, on the AP Calc exam, historically, they've made this a little bit easier by doing the following. And I'm just going to show you this quick one on the next page here. Actually, no, that's it. That's all I cut it off for today. We'll do another example in class on Monday when we go over this. And so that is U substitution.